Hello friends, welcome to Network Tsunami, and today's topic is about transport layer. So transport layer is fourth layer of OSI model. So the first duty of transport layer is to provide process to process communication. Process to process communication. So process is an application layer entity that uses the services of transport layer. So we talked about that network layer. So the job of the network layer is to uh, is machine to machine. Okay, it means source to destination. It means like machine to machine. So this is our source and this is our destination. So this is you, okay, and you are sending to something to your destined user. So this is your destination. Okay, so the network layer main duty is to provide machine to machine communication, not a process to process. Okay, but now we use but now we are talking about process to process communication. So this is not our concern for now. So but still take an example. Let's say particular machine we are running some application which is trying to connect to this machine. So this process want to be connect to the corresponding, okay, that may be same application, maybe a same application. So one side we have server and one application on the other side, so that is client. Okay, so there is a few way to achieve that process to process communication. So the most common ways to ways a client server paradigm. Client or we can say client server model. Client server paradigm. So this is our client process and this is our server process. Okay, so the client we have in local uh, host, so that is called a client. So this client needs services from a process, usually on a remote this remote network, remote host called a server. Okay, so this remote server computer can run several program at the same time. Okay, and this client server can also run several uh, program at the same time, so that's client programs. So that you know that we differentiate them from using an IP address. Okay, so we need one more identifier, so that is called number, port number. So we have range in port number, so that is 0 to 65535. Okay, this we have a port number that assigned already by ICANN. Okay, so wait for a second. We have don't have the space, so just make some space. ICANN. So this is stands for Internet Corporation for assign names and numbers. Okay, so Internet Corporation for assigning name and numbers. So this is basically a non-profit organization that is responsible for unique identity fires. Okay, so we are talking about port number, so let's again talk. So ICANN has divided the port numbers into three categories. So we can call it a range, that is range. So these are well, so first we have well known. Okay, then we have registered, and at last we have dynamic, or we can call them private. Okay, so for better understanding you can draw them like this. So well-known ports are 0 to 1 to 1023. Okay, so these much of uh, port number we have in well known. Okay, then we have registered. So this much of range from 1024 from and to 49151. Okay, so these are registered ports. So after that we still have port numbers. So from 49151 152 to 65535. Okay, so these are dynamic ports. Or we can call private. Private. Okay, so let's say this is client. So this client needs something to identify himself. So that is called a ephemeral port number. Okay, so ephemeral means short lived. Okay, so the TCP TCP and UDP both use these ephemeral port numbers. So the ephemeral port number is recommended to be greater than 1023. Okay, so these need to be greater than 1023. So why? For client server program to be work properly. So this server process must also define itself with a port number. So the server process will can not choose random port number if the computer at this server side run a server process and assign a random port number as the port number. So the server at the client side that wants to access the services and uses its services will not know the port number. So we use well known port numbers. So uh, this range we use for server process. So let's say this is a server and your client PC created a connection with IP address. So now the second identifier is port number. So let's say you are using some client application and this server is using some server application. Let's say HTTP. Okay, so the client uses a port number of any random. Okay, so the server use a port number of well known port number. So the range we have in this well known ports, between these well known ports. So the one example I am using is 80. So 80 is corresponding for HTTP. So HTTP stands for Hypertext Transfer Protocol. So this is a basic information. So now client knows that uh, which process this client want to be corresponding. So now HTTP or FTP and many more. So this client can easily identify the application and run quickly, whether you are using a TCP or UDP. So okay, so in later on I'm going to talk about these topics also. So just wait. So in real time, how it this communication take place. So we have two identifiers. One is IP address and one is port number. Okay, so the combination of IP address and port number is called socket address. Okay, so this is a combination of IP address and your port number. So let's say this is your IP address. So I am taking class C IP address and this is our port number. So the combination of this IP address and port address makes a socket address. So now let's multiplexing and demultiplexing. Okay, so whenever an entity accepts item from more than one source, this is referred to as multiplexing. So many to one. Let's say many to one. Okay, and whenever an entity delivers item to more than one source, this is referred to a demultiplexing. So that is 1 to many. So 1 to So this is multiplexing and this is demultiplexing. So the transport layer at the source perform multiplexing, and the transport layer at the destination perform demultiplexing part. Okay, so let's take an example. Let's say this is your machine and this is client. So you are uh, communicating with each other. So these are some applications you are running. So how the TCP and UDP and know that which process belongs to which machine. So that is responsibility of looking at port number. So the machine can identify that by looking at port number, and after that it will take that TCP and UDP take that and uh, perform that multiplexing and multiplexing part, that which belongs to which server process. Okay. So let's take an introduction about TCP and UDP. So the transport layer either to be a connectionless or connection oriented. So we have two things. Connectionless or connection oriented. Okay. So TCP is a connection oriented protocol and UDP is connectionless. So for reliable communication, the system need to be make a first need to be a make a connection oriented session between each computer. So that is called three-way handshake. Okay, three-way handshake. So first, if the machine wants to make a connection oriented communication, so first machine need to be create a three-way communication, three-way handshake session between each other. Okay. So let's take an example. So suppose this is your PC and this is the PC that you want to communicate. You want to make a virtual connection. So first, that the source machine who wants to communicate sends a SYN message to the destined machine. So SYN means synchronize packet, like that, hey, I wanna talk to you. Okay. Then the destination machine gives a reply with SYN and ACK. So SYN means synchronize and ACK means gives a acknowledgement. So let's, yes, I want to, I'm agree to talk. Then the source machine again sends one message with ACK. So let's talk. So this connection is established and now data will uh, transfer on this virtual session. So whenever we talk about the TCP, so first thing is that this is a reliable protocol, and UDP is unreliable protocol. So why we need this unreliable protocol? Because this is, I'm not saying this is unreliable, this is a lightweight protocol. Okay, so whenever we sending a very big data chunk of data, okay, so we want a reliable communication. So we want every time whenever that segments go to the destined machine, so we want every time an acknowledgement of that received or not. But sometime if we are sending a small data, we don't need this acknowledgement because it will uh, take more overhead to our network. Okay, so this is very lightweight and nice protocol. This depends on scenario. What type of your what is your need? Okay, so I'm not saying this is an unreliable, but if you are sending a big chunk of data, so sometime it is unreliable. Okay, compared to a small chunk of data. So whenever we use this term, reliable communication, so we are talking basically about acknowledgement, sequencing, and flow control. Okay, so the job of flow control is to ensure the data integrity at the transport layer by uh, allowing application to request reliable data transport between systems. So let's talk about flow control. Sorry for my handwriting. So let's start. So the main job is to of flow control is to ensure data integrity at the transport layer by allowing application to request reliable data transfer between systems. So the flow control provide a sending host one side of the connection from overloading or overflowing the buffer in the receiving host. So let's say this is a PC, two systems. Okay, this is a sender and this is a receive. So you cannot just transfer data over and over and over and over. So if you transfer a data like this, so uh, after sending this type of data, the receiver computer face a problem that is called over flooding. So flooding uh, occurs. Okay, so we have something called buffer in our systems. So what it does, so it receives a chunk of that segments, and after receiving, it will send that buffer full. Okay, so it will send a stop message. So stop for some time, and after processing this these segments, it will send that uh, wait for some time, that just I am writing here, it will send that segments processed. So just go. So now that another segments will processed, and after that uh, process goes over and over. So this is how flow control work, by the help of this buffer. So I forget one thing, that is, whenever virtual circuit or three-way handshake setup, so the this uses, it uses sequencing, acknowledgement that I told you, and flow control. So whenever we send a chunk of data, that is called a segment, a pieces of big data, that is called segments. So in subsequent lecture I am going to talk about encapsulation. So just for now, whenever data comes from application, presentation and session layer to the transport layer. So session layer or transport layer chop that data into smaller segment. Okay, so let's say whenever we receive the data and transfer into our segments, so whenever we send that data, if we uh, receive acknowledgement on every small segment, it is going to very painful. So because we are using use very big type of data. Okay, so if we receive acknowledgement on each and every segment, so this is not right for us to use this type of communication. So we have one savior that is called windowing. So this is our savior. So let's say that this is sender and this is receiver. Okay, so sender sends one packet and immediately we have that acknowledgement of that one packet. Sometime we needs this type of communication because we have just a small data. So we can call this a window size of 1, because whenever we send one segment, we immediately get the acknowledgement of that one segment. Okay, send and immediately get that acknowledgement. Okay, so one thing we have more in this. So if we send 1 2 3 at the same time and only get a one acknowledgement. Let's say we have 1 2 3 4 5 6. So this is this much of our data and we got one acknowledgement by receiving 3 segments. So this is called window size of 3. Okay, so every 3 segment we got one acknowledgement. Okay, and if we facing still loss of data, so it the system will automatically reduce the window size of this communication. Okay, so this video is about transport layer. In subsequent lecture I am going to talk about encapsulation process and network layer. Okay, so please subscribe my channel and share my videos and like. Thank you friends.